You know that feeling, right? The sting of ice water or just the warmth of your own hand. Ever stop and think about how scientists take that, a feeling, and turn it into cold, hard data? Well, that's exactly what we're going to break down today. We're talking about how to turn the world around us into a story, but a story told with numbers. So here's the puzzle we're tackling. How can a scientist tool look at a simple beaker of hot and cold water and see a whole story? A story with a beginning, a middle, and an end? Yeah, let's find out. You know, at its core, this is what science is all about. Turning the physical world into data we can actually understand. Think about meteorologists tracking a storm, or oceanographers measuring how salty the ocean is. What are they really doing? They're collecting data. It's how we make sense of everything. But how do they actually do it? Is there just one way? Nope. It's not a one-size-fits-all kind of deal. It turns out scientists have just two, fundamental ways of listening in on the world. All right, so let's break them down. These two ways to measure, this is where we get into the real nuts and bolts of how science is done, and honestly, it's pretty fascinating. Okay, check this out. On one hand, you've got what we call the time graph method. Think of this like a film camera that's just left rolling. The clock is the trigger, right? It just captures everything as it happens, a continuous story. This is absolutely perfect for watching something change over time. But then, you've got events with entry. This is more like a photo booth. You are in control. You decide when to hit that button and snap a picture, capturing one single moment. It's the best way to compare individual, separate events. So see, two totally different tools for two totally different kinds of stories. So let's put that first method to the test, shall we? We're about to watch a story unfold in real time using that film camera approach. So here's our setup for part one. Super simple. We've got a temperature probe, a beaker of ice water, and a beaker of hot water. All we're going to do is track what happens when we move that probe from the cold to the hot. It might seem basic, but trust me, this simple little experiment is going to show us a ton about how we measure the world. Now, the procedure here is what really matters. We're going to set the sensor to record for exactly 60 seconds. We'll start with the probe in the cold water, and then right at the 10-second mark, we're going to plunge it into the hot water. The key thing to get here is that the clock is totally in charge. The sensor is just recording constantly, no matter what we do. And here we go. 10 seconds in, it's time for the plunge. This one move, this single moment, is what our entire story, our entire graph is going to hinge on. So, the 60 seconds are up. And what do we have to show for it? Not just a boring list of numbers. No, we get a visual story. We get a graph of temperature versus time. Okay, so collecting the data, that's just half the battle. Now we've got to figure out what this graph is actually telling us. Let's dig in. One of the coolest things we can pull from this graph is something called response time. So what is that? Well, it's basically how long it takes for a sensor to notice a change and fully react to it. You can think of it as how quickly our tool can catch up with what's really happening. And that, you can imagine, is absolutely crucial for getting accurate measurements. So, how do we find it? It's actually a really simple process. First, you just find the highest temperature on the graph. See what time that happened. Then, just subtract those first 10 seconds before we dunked the probe. And voila! Whatever is left over, that's the probe's response time. We just pulled a really important scientific value right out of that visual story. Okay, so that was our film camera in action. Pretty neat, right? Now let's completely switch gears. It's time to check out the photo booth method, where we're just capturing one single moment. And for this one, we're moving from beakers to something a little more personal. A human hand. So we're not measuring a process over time anymore. We're measuring a single specific event. What's the temperature of this person's hand right now? And the way we do this is totally different. Someone just holds the probe and we wait for the temperature to kind of settle down and become stable. Then, and this is the most important part, we press a keep button. We are telling the sensor, okay, record the data now. The scientist is in control. The clock has nothing to do with it. And check out the result. Instead of a curvy, winding graph, what do we get? A super clean, simple table. Each person has a number, and next to it, one single temperature reading. That's it. It's direct, it's to the point, and it's absolutely perfect if you want to compare different people. So, let's wrap this all up. What's the big takeaway? Well, we've seen there are two main ways to grab data from the world: time-based and event-based. Time-based, that's your film camera, giving you a continuous story that's amazing for seeing how things change. And event-based, that's your photo booth, capturing specific moments that are perfect for comparing things. And maybe the most important lesson of all, knowing which tool to use for the job, well, that's one of the biggest decisions a scientist has to make. And that kind of leaves us with one final thought, doesn't it? We just saw how a simple little probe can tell a story about a beaker of water, or even a person's hand. So it makes you wonder, what stories is the data all around you just waiting to tell? And which method would you use to hear them?